Recording. All right, so today we're doing Pythagorean Theorem. We're mostly looking at the application. A common question that I've been getting is when do we estimate and when do we keep it in radical form? Well, once it's in a word problem, usually you're going to do the estimating. For instance, if I'm ordering an amount of fence, we use Pythagorean Theorem when we are in a situation where we're looking for a measurement where we can create a right triangle. So for instance, on a coordinate plane, if I have a diagonal, I can create a right triangle and figure out what that diagonal is. That would be a situation I would utilize the Pythagorean Theorem. But if that distance were some fencing that I were ordering, in that case, I'm not going to go to Home Depot and say, I'd like 5 rad 3 feet of fencing. So in that case, we're going to want to estimate it. Do you understand? Yes or no? Okay. Quick review. Remember the two sides of the right triangle that surround the 90-degree angle are called the legs, and the biggest side, which is opposite the 90-degree angle, is called the hypotenuse. All right, one way that they might present Pythagorean Theorem is they might put it on a coordinate plane or on a grid, and we can always find our vertical and horizontal if they tell us that it's 1 centimeter grid paper. And in that case, I can just count squares. If this is 1 centimeter, it's 1, 2, 3, 4, 5, 6, 7, 8. And this would be 6. Now, we should know those numbers 6 and 8. Does anybody know what this measurement is, the diagonal, right away without doing any work? Yes. But what is it?
You just take the ruler and measure it.
We can't measure because these are not full boxes. You can't measure the diagonal. That's why we do Pythagorean Theorem. But you should be able to figure this one out right away. Yes.
The hypotenuse is 10.
How do you know that, John?
Because 8 squared plus 6 squared is 100, and the square root of 100 is 10.
Anybody else know that from somewhere? Yes. It's a Pythagorean triple. Remember, 3 times 2, 4 times 2, 5 times 2. It's one of the 3, 4, 5 Pythagorean triples. If you double it, it's 6, 8, 10. And that should be familiar to you, but we would substitute it in for a squared plus b squared equals c squared and prove our way. John did a lot of mental math really quick. But do you understand how they could present that on a coordinate plane? Now, I'm going to skip through a lot of this because we've covered most of it. Sometimes they give us the hypotenuse, and we have to solve for the missing side. All right. Find the length of a diagonal of a rectangle that measures 3 inches by 4 inches. The first thing we have to do is draw that diagonal. A diagonal goes from corner to corner. All right. Do we know that measurement of the diagonal?
No.
So we call it x. So I start with my a squared plus b squared, and I substitute in. And what are you noticing, Daniel?
It's a Pythagorean triple.
It's a Pythagorean triple, 3, 4, 5. So x is 5 inches. Okay? But you should be proving your way. Questions? All right, so let's try another one. Find the length of a side of a square whose diagonal is 4 meters long. Diagonal is 4 meters long. So I'm going to label my diagonal. And now how would I go about figuring this one out? Caleb?
4 squared plus a squared plus b squared.
Okay, can anybody be more explicit? John?
A squared plus b squared equals 4 squared.
A squared plus b squared Okay. You're leaving something out, though. Yes.
A squared plus b squared plus... Oh wait, a plus b equals 2?
No. Yes.
Well, wouldn't they be 4? Like A and B?
Why? Come on, guys. Saffron.
A equals b.
Okay. So how would you write this? Why do you say A equals B?
Because it's a square, so the sides are equal.
So what are we going to call it if we don't know its name?
A.
What do I call something when I don't know its name? X, right? So what would this be? Down here. Aren't they both X? So what do I substitute in?
X squared plus x squared equals 4 equals 16.
Okay. Now what? Fat
2x squared equals 4 squared.
equals 16. Now what?
We divide by 2.
Yep. And we get x squared equals, and x is equal to, or square root of 8, x is about, notice I change it to the about, 2.8. Square root of 8 is very close to 9. So is everybody clear on that? It's a square. All right, let's try the next one. To the nearest length, find the length of the diagonal of a rectangle with the width of 4 feet and a length of 10 feet. I'm going to skip this because it's pretty similar, right? Okay. If you want to pause the recording, you can pause it now and check your work. Because I really kind of want to show you a bunch. Okay, a car drives 20 miles due east. Draw the diagram. It's drawing 20 miles east. It's drawing 20 miles east. And then it's going 45 miles south. Okay? Now it says, to the nearest hundredth of a mile, how far is the car from its starting point? The closest distance between 2 points is a line. So we have to find that distance. Notice, right here, nobody is showing. So now, notice, God didn't come down and say, hey, it's time to use the Pythagorean Theorem. But we've created a nice little right triangle here. And we can use it to find a distance. So, we're going to do it. And I want you to do this one because big numbers, I will give you a big number. All right, so let's get started. All right, so step 1, let's start out with our a squared plus b squared equals c squared. Okay, step 2, we're substituting. What is a squared? 20 squared, 45 squared. 20 squared is what? And 45 squared is? Okay, when I add them together, I'm here. Now, I can estimate this to almost 2 different tries. Okay? Now, I'm doing this because look at what I do when I have big numbers. Pay attention. I start going to my tens. I can first estimate it between 10 digits. So I'll say 10 squared, 100, not even close. 20 squared, 400, not even close. 30 squared is what?
900.
40 squared.
1,600.
50 squared.
25,000.
2,500. Okay, so now I have narrowed it between 40 squared and 50 squared. Okay? 40 squared is 1,600. 50 squared is 2,500. This is definitely closer to one number versus the other. It's not even halfway in the middle. So now I've not only eliminated 40 squared, 41, 42, 43, 44, and this is 2,400 is not halfway in the middle. It is definitely closer to 50 squared. Do you understand? I have eliminated 45 and lower. So now I'm down, I know it's not 50, so now I'm down to 49 squared, 48 squared, 47, 46. 46, too close to halfway. I'm going to go with 49. That was my first guess this morning. So 49, when you multiply 49 and 49, you get 2401. It's a little low. So now can we estimate it? Yes. 0.8, that's a little high. It's a little far off. It's only 25 from?
49.5.
I would even go lower. It's very close to, it's closer to 2401 is 49 squared, right? And 50 squared is 2,500. Do you understand? So is it closer to the 49 or is it closer to 50? For 2401, 2425 is closer to 50 or to 49? So it's not even halfway in the middle. It's way less than halfway. So I'm going to guess 49.2, 49.3, 49.1. And I guessed 49.2 and it was almost right on. So do you understand how I narrowed down those big numbers? Yes or no? Okay. So the answer we came up with was 49.2. Now, the next thing I can do is reduce it to a radical. When I reduce it to a radical, again, what number do we know perfect square divides into it? Ben?
25.
25. 25 times 100 is 2,500, right? It's not 25 times 100. It's too much. Notice there's 3 25s less. So 25 times 97, so it's 5 rad 97. Do you understand how I get myself close to those big numbers? Yes. Yes, because I want to see that you can start doing that. Yes.
Would you have accepted 49?
Yes. I would have, if you had said about 49, I would have accepted it. Yes. But can you do the radical? And if you can do the radical, the square root of 97 is very close to 10. So I'm going to say like 9.8. 9.8 times 5, it will get you there. Okay? All right, let's look at the next one. This is a good one. I love this problem. Find the legs of a right triangle if one leg is twice as long as the other. Let's call one leg what?
Eggs.
And the other one? Okay, go. Finish this one up. Pause the recording. Finish this. All right, so let's set this up. What do I substitute in, please? Gabby.
X squared plus 2x squared equals 10.
Okay.
X squared plus 4x squared equals 100.
Wait. X squared plus what?
4x.
Are you sure?
Oh, she's distributing it to x.
Equals 100. What do you guys think? Is it 4x squared? Okay, it is, because remember, it's the side squared. Did everybody do that? Sorry, Gabby, I didn't mean to doubt you, but I want to make sure everybody else was listening. You're right, it is 4x squared. Because if you only square the x, you're only squaring a portion of the side. So now we have 5x squared equals 100. 5 and x squared is equal to 20. And we get about 4.4. Are you guys good? Okay, let's look at a couple other word problems that we get. Shh. I'm going through them quick because they came up last year. The ladder problem. Okay, you will always have a wall, a ground, or a base. When they say how far, that's the ground. When they say how high, that's the wall. Set up what they're giving you. Okay? You will also have, they also use like a flagpole. A flagpole and a guide wire. So if I have a pole that's 20 feet high, how long should the wire be to hit the ground 8 feet from the base? So the base is the ground. That's my 8 feet. And so my wire is this, the hypotenuse. Are you guys okay on this? Okay, now, I will put something like this up on your quiz. Now, if you look, we're looking for y. However, before x, we're looking for x. However, before we can do that, we must find this. And I can find this because I know this and this. What is this measurement here? The dashed line to the left. 6. So in an 8, and we know that this is 5 because that's 5. Let's call that other unknown. So if this is 6 and this is 8, what is this measurement? 10. Why? Because it's a Pythagorean triple. So then all we're really having to do is 10 squared plus 5 squared equals, our x squared. Okay? And that is the end.